So, we are going to move on into Chapter 9. We are actually not only doing 9.5, we are also doing 9.4. I just didn't put that here. 9.4 is called the tangent ratio. 9.5 is called the sine and cosine ratios. So I don't really understand the thought process on the ordering of your book, why they split them up. You should have seen this last year. This is the very foundation of Chapter 9. Okay? The tangent ratio and the sine and cosine ratios. So, we're going to begin. We're learning trigonometry, which sounds like an extremely difficult word, but all it means is the study of triangles. Literally it. So, in particular, we're going to be learning about right triangles. All right? Because they build up everything in life. I know in my husband's work, the people that he works with, they know Pythagorean triples. They don't have to look them up. They just ended up memorizing them. Not because of a book, but because if you see the same thing every day, you end up memorizing them and learning them. Okay? So, the first thing is, if you have a right triangle and it has one missing side, you can use the Pythagorean theorem. I do want you to write that down. This is going to help you learn how to problem solve in this section. So, in a right triangle, if it has a missing side, you use the Pythagorean theorem. All right, and we did the Pythagorean theorem on Thursday and Friday. And it was c squared equals a squared plus b squared. I used it this way because it helps you decipher if it is obtuse, acute, or a right triangle. Or you can write it a squared plus b squared equals c squared. All right, what letter matters the most out of all three of them? C. What does C represent? The hypotenuse. Where is the hypotenuse always located? Across the right angle. And what do we know about its measure?
It's the longest side.
It's the longest side, which means it's going to be the biggest number. Longest side. Okay, so whenever we did that section, a lot of people struggled with figuring out which is the hypotenuse. You're going to need to know the hypotenuse for this section as well. Okay, so it will never change. It's always the longest side and across from the right angle. What you're going to learn today are called trig ratios. If a right triangle has only given you two sides, you can also find the missing angles using what we call trig ratios. So I do want you to also write this down. Another problem that you're going to be given is you're going to be given two sides, and it's going to ask you to find the missing angles. To do that, you use what we call trig ratios. The word trig is short for trigonometric, which nobody wants to write. So when you see trig, that means trigonometric. Yep. So trig ratios are what we're learning today. So it's like the very foundation, the stepping stone to the rest of the chapter. That's why we're emphasizing it over 2 days. And the last, if a right triangle has only given you a side and an angle, so one side, one angle, you can find all the missing sides and the angles using trig ratios. So trig ratios help you find anything in a right triangle, the sides, the angles, anything that you need. So I highlighted right, or I put it in bold or capital letters, whatever you want to say, because in like a week, we're going to be dealing with non-right triangles. So these things only apply to a right triangle. Is that trash? Trigonometric. All right, so you're going to learn what a trig ratio is. What does the word ratio mean? Do not use the word ratio to define the word ratio.
Yeah, what you said. Don't it got the little two things?
It's one number against one number.
Periods.
Yeah. So a ratio is a relationship between numbers.
Yeah, I knew that.
Like the relationship between, let's say, No, not peanut butter and jelly. Like girls to boys. Yes, you do need the right ratio of peanut butter to jelly. I agree. Or like when I eat apple pie, I need the perfect amount of apple pie and perfect amount of ice cream. You see what I'm saying? Vanilla ice cream.
No, it doesn't even sound.
It's called a la mode. Oh my goodness, you're crazy. So, you're not actually going to see it. We're actually going to do this. Girls, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 right now at least. There are 9 girls to 2, 4, 6, 8, 10, 12. To 12 boys. You guys are hilarious. There are 9 girls to 12 boys. You're not actually going to see it written like this. When we're talking about ratios, we're actually going to be talking about fractions. Do we reduce in math class? Yeah. We do every single time. So this would reduce to 3/4. You're going to be finding the ratio of the sides of a triangle. Okay? So as long as you learn which one goes where, you'll be A-okay. All right?
Sweet.
So a trigonometric ratio is the ratio of the lengths of 2 sides of a right triangle. So instead of girls to boys like I just did, you're just going to be looking at sides and writing in those numbers. Okay, so I'm going to show you an example. We're going to have triangle ABC be a right triangle. We're going to find the sine, cosine, and tangent of the acute angle A. So that sounds like rocket science. It's not actually going to be. So we're going to do one thing at a time. All right, go ahead and draw a right triangle like so.
Can I like draw a fish in the
If you want to. All right, so we have this right triangle. So you're going to learn the word sine, cosine, and tangent. All right, so they represent a specific kind of ratio. If you look on the right side of that's actually left to you. Left side of the classroom, under your homework, I wrote SOHCAHTOA. Y'all see it?
Yeah.
SOHCAHTOA. This is what you eat, sleep, breathe in this section. So I want you to write this on your paper. So, what do you think S stands for out of those 3 words? Sine. So this represents sine. Sine, S-I-N-E. S-I-N-E. It's a word. Sine. You see O-H? So this will help you figure out the ratio. Sine is going to be the opposite side over the hypotenuse side. I'll show you on the screen. You can look at it either way. So sine of angle A is the opposite over the hypotenuse. So if you look at what was written, do y'all see how they wrote sin? Okay, it represents the word sine, so you don't have to write out the whole word. But you don't say sin to me. If I say, tell me what this word is, and you say sin, we're not gonna be on the good page, okay? You'll annoy a math teacher in like 2.5 seconds if you say that. So don't do it on purpose now. Sine. If you look, what's next to it is a capital A. This, listen, is highly important. If you do not write this, your whole problem will be incorrect. Sine of angle A. Here is why. If you look at the triangle, the way that they mapped it out, you're finding the trig ratios in perspective of angle A. So the opposite of angle A was this little side right here. The hypotenuse will never change regardless, but it's right here. And then the side we call adjacent is what's left. Okay? So if you look at it this way, if I'm coming through this door and I'm facing this way, what is my opposite? For that wall. Okay, yes, you. If I were coming from that door, my opposite would be
That door.
there. So what matters is this letter tells me what perspective you're looking through this triangle. Because if you don't write it, I don't know if you're talking about from angle B or angle A. Here's why. If you're coming from angle B, I'll write it in blue. If you're coming from angle B, which side would be opposite?
A.
Nope.
Sine.
Nope.
B.
B, opposite. The way to do that, look at the triangle. If you were to turn it towards you, what side would you be directly looking at? And that would be your opposite. Your opposite will never be the hypotenuse. Yes, ma'am.
Could I have Miles Brooks for a minute, please?
Yes, ma'am.
Okay.
Your hypotenuse will never focus. Your hypotenuse will never be your opposite and will never be your adjacent. Your hypotenuse is your hypotenuse. The hypotenuse is always across in the right angle. It's always the longest side. It will never be opposite or adjacent. If you do not remember that, I suggest that you write that down. Never opposite and never adjacent. So, from angle B, your opposite would change to side B because it's directly across from it. And then your hypotenuse would stay the same. Your adjacent would change. So, whenever you're doing these, you have to tell me what letter you're coming from. Okay? So don't just dismiss it and write sine equals. That will not be okay. Alright? So the next kind is cosine. C-O-S is how we represent it. If you look at it over here, sine was so. Cosine is ka. And it is A over H. What do you think A stands for?
Adjacent.
Adjacent over hypotenuse. Sorry. Adjacent over hypotenuse. This one people struggle with the most, even though you guys use the word ka all the time. You just spell it wrong. It cannot be. Here's what I mean. It's supposed to be spelled like this. Not like this. Because opposite over hypotenuse is which of the functions? We just did it. It's sine, not cosine. Cosine is spelled like this. Cosine is adjacent over hypotenuse, not opposite over hypotenuse. Okay, so if you say SOHCAHTOA, make sure that you know that. That's the one that students most often mess up. All right, and the last is called tangent. We write tan. So tangent from angle A will be opposite over adjacent. So O over A. So that's what TOA comes from. So this is what we're doing this entire lesson, finding sine, cosine, and tangent of specific angles. Okay? It is the stepping stone to finding everything that you need in trigonometry, in right triangle trigonometry specifically. All right? We're going to do an example together. Oh, and this is one way some people remember it. It sounds like Sacagawea or like an important Indian name. But SOHCAHTOA. You'll remember it even if there's some things, almost died there. There are some things in high school math that you will probably just not remember, and that's okay. If you don't use it later, you're probably going to forget it. SOHCAHTOA, it's not one of them. You're just going to remember it the rest of your life. I have friends who've been out of high school 10 years, and they remember SOHCAHTOA. They might not remember what it does, but they remember SOHCAHTOA. Okay? So, you should remember it too. Alright? So, we're just going to keep going. Go ahead and draw this triangle. This right triangle. On your notes, it'll say the word classwork when it's time for classwork. So you have a right triangle. What side is the hypotenuse, regardless of what angle we're coming from? Across from the right angle, so that'd be 65 here. That will never change. Just like in my classroom, it doesn't matter what perspective you're coming from, this is my desk, right? So it's never going to change. So, we're going to do the first And it is sine of S. All right, so sine of S. So we're coming from the perspective of angle S. So what I suggest, what I tell all my students to do is to label your triangle. What is the opposite side of angle S? 63. So this is your opposite, which leaves 16 to be your adjacent. All right, if I hit next, the words are going to disappear, so I'm going to write them. Yes, dear.
Okay, so S is what?
Angle S is the perspective we're coming from.
So S is the perspective.
Yeah. Angle S decides what's opposite and adjacent. If we're coming from angle R, the opposite will change and the adjacent will change.
Okay.
They'll flip. That's what angle S is important for. Good question. When I hit next, it'll disappear, but I'll write it on the screen or the board. We're still coming from this perspective of angle S. All right, so sine is so it's opposite over hypotenuse. So what is the opposite of angle S? 63, and the hypotenuse is 65. So your fraction will look like 63 over 65. So that's part of your answer, according to the directions. Because it says write it as a fraction, so boom, we've done that. And then as a decimal, round it to 4 places. So how do we find the decimal? Plug it in and hit S to D. So go. And hit S to D.
Oh wait, is that what that means right there? S-I-N?
S to D. Yeah, these we'll use at a different time. No, if you type in what we're doing right now, it will not work. You will not get the correct answer. These are just fractions. It's not going to tell you that. These help you find the measure of angles and sides. So later on, they will help you. All right, S to D, what do we get?
9692307 repeated.
Okay, but we're rounding to 4.
0.9692.
0.9692, so you should circle that. Make sure you read the directions on rounding. Second portion, finding cosine of S. Cosine is what side over what side? It's
Car is adjacent over hypotenuse.
adjacent over hypotenuse. So what is the adjacent to angle S? 16. And the hypotenuse is 65. 16 over 65. Circle that portion as your answer. Plug it in your calculator, and you will have to round. Tell me 5 decimal places, and I'll explain how to round. 2461, then there's a 5 right after it? Okay. So that 5 makes the 1 round up. So that should not be 2461. It should be 2462. Okay? If the number right after the one you're supposed to stop at is bigger, or 5 or bigger, you round up. If it's 4 or smaller, it is what it is. All right, questions on this? So now we're going to do the other portion. So from angle R, I can immediately label the hypotenuse. What is still the hypotenuse? 65. It will never change. From angle R, what becomes the opposite?
16.
And the adjacent? 63. So we do the same thing that we did before. Sine is still opposite over hypotenuse. So what is my new opposite? 16. And my hypotenuse is 65. We've already done this one. What is 16 divided by 65? 0.2462. They're the same. There is a reason for that, and you'll learn that in a minute. Cosine of R is adjacent over hypotenuse. What is my adjacent? 63. And my hypotenuse is 65. We've already done that one as well. There is a reason for this. You're going to learn tomorrow that these cosines and sines of a right triangle have a very special relationship with each other. They're called complements. Not like a compliment that makes you feel good, but complements that work together. Remember how supplements add up to 180? Complements add up to 90. Here's why. You have a right triangle, correct? Yes. How many degrees fit inside of a right triangle? 180. How many is taken up by the right angle? 90. So what's left for these two is 90 in general. So cosine and sine have a very special relationship. We're going to do this again tomorrow, and you'll see exactly why. You can rewrite sine in terms of cosine, and you can rewrite cosine in terms of sine. And it's not super difficult. You just have to learn the concept. Okay? But we're going to come back to this and why they equal the same thing. Okay? Are there any questions on how we found the ratios? Yes? All right. The last portion, I just literally said that to you. The last one we're going to do, or going to review together, is finding tangent ratios. So this in particular is from 9.4, but it is the same idea, except for now we're using tangent. It's a different triangle. We have 18, 80, and 82.
Draw this.
Yep, on your notes. I didn't notice this earlier, but find all of the trig ratios. So we're going to do all of them, sine, cosine, and tangent. From angle R, and then from angle S, and then angle R. So we're going to find sine of S, cosine of S, and tangent of S to begin with. So if we're coming from angle S, which side is the hypotenuse? 82. That will not change. What is the opposite from angle S? 80, which makes 18 the adjacent. All right, so in your directions, it will always tell you how to leave your answers. This one says reduce fractions. So what do you think your answer is going to look like? A fraction. All right, so sine is what side over what side? Opposite over hypotenuse. So what number goes on top? 80. And then the hypotenuse is 82. So reduce that fraction. What do we get? 40 over 41. The next one we're finding cosine of S. Cosine is ca, so adjacent over hypotenuse. What is the adjacent to angle S? 18. And my hypotenuse is still 82. So what do we get? 9 over 41. And then tangent of S. Tangent, soca, toa, it's opposite over adjacent. So what is the opposite? It's 80. And the adjacent is 18. So reduce it, you get 40 over 9.
What if we put it in improper fraction?
Then you would be incorrect. That's not going to help you later on. This is an improper fraction. He meant mixed number.
Yeah.
If you put it as a mixed number, that's not going to help you. Later on, what we're going to do, you're going to see an equation that looks like this. Tangent of S equals 40 over 9. A lot of you see that there's a button on your calculator. That button would help you solve for angle, it's not SD. That would help you solve for angle S. So if you write it as an improper fraction, your calculator is going to say, try again, doofus, because that doesn't work. That makes sense? Yes, it's got good insults. Okay? So we're going to leave it here for now, but in like 2 lessons, you're going to see an equation that looks like that. Now we're going to find sine from angle R, cosine from angle R, tangent from angle R. So if we're coming from angle R, which of my sides change? Adjacent and adjacent and opposite. So what becomes my opposite? 18, which makes 80 be my adjacent. But then you do the same thing. Sine is opposite over adjacent. So what's my opposite now? It's 18. What? Sorry, opposite over hypotenuse. I'm sorry. Sometimes you're in like, what is that called? Autoplane? Autopilot. Autoplane. Y'all, it's a Monday, okay? Opposite over the hypotenuse, which is 82. We know this reduces to 9 over 41. Cosine is adjacent over hypotenuse. So that'd be 80 over 82, which reduces to 40 over 41. And the last, opposite over adjacent, which is 18 over 80, which reduces to 9 over 40. So it looks like a lot right now because you're learning for the first time. When you've done this for a long time, it becomes second nature. Also, if you're in Algebra 2, there's an entire chapter over right triangle trigonometry. Yeah. So you're ahead of the curve, especially if you're taking it this year.
Say goodbye.
All right, so this is your classwork, but you want to pause. Have you started right triangle trigonometry? Oh. All right, so I'm going to explain this to you. Listen, this is your classwork. It goes on your classwork paper, the one that you're going to turn in. So listen, it says find the trig ratios of the smallest acute angle. So, and it says reduce fractions. So your answer is going to look like a fraction. It doesn't tell you exactly which angle it comes from, but it says the smallest acute angle. Every angle corresponds with the side across from it in a triangle. So, you're going to find the smallest side that is not the hypotenuse. And the hypotenuse would never be the smallest side anyways. But out of 12 and 5, which is the smallest side? 5. What angle is across from 5? G. So angle G would be the smallest acute angle in this triangle. On number 2, what's the smallest side on this right triangle?
65.
Okay, so you come from the angle that is directly across from it because 65 is the smallest side. Angle F will be the smallest side. This one is a little different on number 3. Which is the hypotenuse? 2. Okay. The other legs, they're the same. Right? Square root of 2 and the square root of 2. Do not let this scare you. The square root of 2 is a number, just like any other number. So, what you'll do, if the sides are congruent, what kind of triangle is this? You have 2 sides that are congruent. It's an isosceles triangle. So it doesn't actually matter which angle you come from, F or G, because they're going to be the same. It's going to be a 45, 45, 90-degree triangle. Okay, so those are my PSAs for this little page.
Thank you.
You're welcome. All right, so you're finding all 3 for each of them. Go. Open up your student journal, page 270. It's fine. 270. Determine which of the 2 acute angles has the given trig ratio. So you should see in the middle-ish of the page on 270. So we're finding out which angle has cosine equaling 24 over 25. So, what is cosine? What is the ratio? The what side over the what side? Adjacent over the hypotenuse, which means 25 has to be the hypotenuse. 24 has to be the adjacent, which means 7 is the opposite. So which angle would give all of these the correct spots? What is opposite of angle 7, or side 7? F. So it's coming from the perspective of angle F. The second is harder because you have a decimal instead, but it says we're using sine. Sine is what side over what side?
Opposite over
Hypotenuse. So which side is the hypotenuse here?
14.
The square root of 14 is the hypotenuse. So, what I would do is find sine of, let's say, E. So we're coming from the perspective of angle E. Here you would just do trial and error. So if your ratio of sine of E equals 0.38, then you were coming from angle E. If it does not, then you were coming from angle F. Okay, that's the idea you're coming from here. So sine is opposite over hypotenuse. So what is the opposite of angle E? What is directly across from angle E? Square root of 2.
What?
25.
No.
If you cannot, listen, if you cannot figure out what is opposite, take your book and turn it towards you. If you're looking from, where are we? Angle E, what is directly across from angle E? And it is the square root of 2. If you cannot see it, then turn your page. All right? If you type this into your calculator, you get 0.377. Something, 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 something. What is that? Round to.
4. Oh, no.
0.38. It does round to 0.4 if you're rounding there, but we're trying to make it match that. So, is angle E the perspective we were coming from? Yeah. Yes, it was. All right, we're going to do this one together. It is possibly the last one, I don't remember, for today. Find the value of each trig ratio from the largest acute angle to the nearest thousandth. So you're rounding to the thousandth place. Most students don't know where that is. How many zeros does 1,000 have? 3. So you're going to 3 decimal places. So the hundredths has 2 zeros, so you round to 2 decimal places, and so on. Okay, so we're rounding to the nearest thousandth, so 3 decimal places. We need to come from the largest acute angle. Why didn't I just say the largest angle? The largest angle would be 90. You cannot do SOHCAHTOA from 90 degrees. You cannot. So, to figure that out, 50 is a hypotenuse, because it's directly across from the right angle. Alright, so we have the hypotenuse. We need to figure out which A or C is the largest acute angle. So which of the 2 legs is the longest side? 48. So what angle is across from 48 degrees? Angle A. So we're coming from the perspective of angle A. If you have a hard time figuring out what angle is across from, this whole side is 48 degrees. C and B are literally right next to the number 48, so they're right next to it. It's not across. So the angle that's left out, that will be the opposite. All right, so we're coming from the perspective of angle A, which means 48 is my opposite, and 14 is my adjacent. So all we do from here is SOHCAHTOA. So sine, what angle are we coming from? A. So SIN of angle A. All right, equals what side over what side? Opposite over hypotenuse. So what is my opposite? 48. And what's my hypotenuse?
50.
All right, so we're rounding to the nearest thousandth. Plug that into your calculator. Should get like 96. Yeah, 0.96. Since we're rounding to the thousandth, if you want to, you can put a 0 there. It doesn't really do anything there. But you can put it there if that makes your heart happier. Cosine of angle A is adjacent over hypotenuse. So what's going to go on the top of my fraction?
14.
14. And on the bottom?
50.
50. 14 over 50. Should be 28.28.
Do you know this from like doing it before, or you just know it?
Well, if you have 50 questions in a test, they're each worth 2 points. So 2 times 14 is 28. That's all I was doing. 2 times 48 is 96. Okay. I don't know if I know the last one. Tangent. Tangent of angle A is opposite over adjacent. So opposite would be?
48.
And adjacent would be? See, this one's not as easy to do.
Let's see, what is that? I bet you I can tell you. 0.6.
3 point. How is it going to be less than 100% if 48 is on top and 14 is on the bottom. That's all. 3 point, we're rounding to the thousandth, so 3 places. 3.429. You should get 8.5, and the 5 makes the 8 round up to a 9. You guys are going to begin this one on your classwork paper.